All right, let's talk about troubleshooting steps for the turbocharger itself. We've already talked about the simpler stuff that should be checked, such as the wastegate actuator, the controller. We talked about the turbo oil check valve, the scavenge pump, and so forth. But now let's talk about the turbocharger itself. Honestly, not a lot usually goes wrong with these things, but let's start with the cold section. So this is the compressor inlet right here. And what you're checking for here, first of all, you can grab the shaft and try to wiggle it. There should be little to no play. Sometimes when there's, when the bearings don't have any oil on them, you might get a little bit of axial play, but not much. And you're also looking for FOD damage. So as you look at the leading edges of these blades, because this is where air comes in, you're looking for evidence of a screw or other kind of FOD that has been ingested here, which will cause damage to the leading edge of those blades. And that would be a sure sign of problems there. Okay, and then of course you can, if you look at the outlet of the compressor, you can't really see anything there. But let's go to the hot side over here. So here's the turbine. Now you might think this is the leading edge of the turbine blades and that's where you would be checking for FOD damage. But remember, with the exhaust side, this is the inlet and this is the outlet. So this is really the trailing edge of the turbine blades that you're looking at. So that's not where you're going to typically see leading edge damage on the turbine blades. So for that, you might be able to see it by looking at the turbine inlet here, maybe. Yeah, you can. I don't know if I've got the camera angle right here. Maybe I can shine a light backwards and we'll shine it in this way. But notice, if you can see this, hopefully the angle is right, but you should be able to see the leading edges there of the turbine blades. And you shine a flashlight in there, you can definitely see if there's any damage there. What you can also see is behind the turbine blades on this side is a heat shield. And that heat shield sits between the hot section and the center section where the bearings are. And you can tell if the turbine wheel has been rubbing or scraping against that heat shield, which would be a bad thing. But you can also shine a light in this way. You can either shine it in the turbine inlet and look at the outlet, look into the outlet, and you can see, you can rotate the turbine wheel around and you can see the leading edge pretty well that way as well to look for any FOD damage. And by shining it in this way at kind of an oblique angle, you can get a look all the way around the circumference of the heat shield to make sure there's no scraping of that turbine wheel on the heat shield. And of course you can wiggle the shaft as well. So this turbocharger looks really good. There's no evidence of FOD damage. There's no sloppiness in the bearings. There's no scraping. We're also obviously looking for cracks in the turbine housing and so on and so forth. Where you would often see scraping there between the turbine wheel and the heat shield is if these turbines have been over-temped. So these usually have a turbine inlet temperature of 1650 degrees Fahrenheit or so. And they get red hot even at that temperature. So if you allow it to over temp at the high RPM that these things spin at, sometimes over 100,000 RPM, you can get blade stretch. And that's when it can begin to rub and create all sorts of problems. And pretty soon you're going to need a turbo overhaul. So a good idea is to back this off and maybe set an alarm on your engine monitor for 1600 Fahrenheit instead of 1600 degrees Fahrenheit instead of 1650, just to kind of back that off just a little bit. Now here you can see also we have our center section, and so let's see here. This actually sits, this is the bottom. So your scavenge pump is pulling oil out of the center section here. And then it comes in the top side, I believe right there is where actually no, it's right here. Here's the fitting where oil comes in to feed the bearings. And then here's where the scavenge pump draws that oil out of the center housing so it doesn't collect. Because remember, the seals on either side here for the hot and the cold section They're not high pressure rubber seals. They're metal seals. They're more like piston rings. And they're not really designed to deal with high pressure oil or a lot of oil sitting against them. So if the scavenge pump is not removing all the oil, or if the turbo check valve is not shutting off when you shut the engine down and it's letting oil collect in the center housing, you might tend to see oil drips when you come into the airplane. You come into the hangar in the morning and you'll see that. You could also see exhaust in the tailpipe, oil in the tailpipe if the seals are not sealing properly, either because oil is collecting or if the seals go bad. You can get oil that goes past those seals. It'll make the tailpipe oily. And some of that oil film will also get into the compressor side. If it's a pressurized airplane, you might actually get an oily mist in the cabin. We had that in an Aerostar once because of a faulty seal in the center housing. But those are the basic things that you can check on an annual inspection to make sure that the turbocharger is in good shape, that it's going to give you maximum performance, and that it hasn't suffered some kind of FOD damage or overheat damage. One final maintenance topic with regard to turbochargers has to do with turbocharger clamps. Now, these are known as V-clamps because when you look at the two mating surfaces that come together, there's a bevel machined on this side and there's a bevel machined on this side. So when you bring these two together, the V shape of this clamp, you can kind of see why it's called a V clamp. When this squeezes together, it's going to draw those two mating surfaces together. So the way that this clamp works is you take this nut off, you feed the bolt through here, and as you tighten the nut, let's actually put this around the joint so you can kind of see how it works. But as you tighten this nut and it squeezes this together like so, and that draws the two mating surfaces together. Now, of course, these clamps are subject to a great deal of heat, so they should definitely be inspected on a very regular basis. Every time you change the oil and you lubricate the wastegates, you should take a hard look at these turbocharger clamps as well. Now, these are spot welded turbo clamps or V-band clamps. There's actually a recent airworthiness directive, 2023-09-09, that addresses these clamps. It basically limits the life of them to 500 hours, and then they must be replaced. And actually, that is the case whenever these clamps are installed on the tailpipe side or the turbocharger outlet, the turbine outlet. In the case of my Turbo Twin Comanche, the same part number is installed on the turbine inlet as well as the turbine outlet or the tailpipe side. The airworthiness directive, though, only addresses the clamp on the tailpipe side for some reason, the outlet to the turbine. Not sure why that is. But obviously the clamp on the turbine inlet is also subject to quite a bit of heat, and it should be inspected as well, even though it may not be subject to the airworthiness directive. There's a lot of turbocharged airplanes that have these spot welded clamps. If you happen to have a turbocharger that has riveted clamps, those are not subject to the AD. There's also some airplanes out there, for instance, on the Aerostars. The original Aerostars did indeed have a clamp like this on the tailpipe, and if you had one of those, it would be subject to the AD. But it seems like most Aerostars have had the original stainless steel tailpipe replaced with an Inconel tailpipe by STC. And those tailpipes are actually bolted onto the turbo rather than clamped on with a V-band clamp. And the airworthiness directive specifically excludes those Aerostars that have been modified through that STC to have the Inconel tailpipes. But those same airplanes, even though they're not subject to the AD, will still have a V-band clamp on the turbine inlet side. So even with an airplane like an Aerostar where you're not subject to the AD, you still want to inspect these band clamps. You want to inspect them for separation of the spot welds or any kind of cracking or anything. This is obviously a well-worn, very tired clamp that is not going to be used very much longer, that's for sure. But that is something else to be aware of on your turbocharged airplane.